In this BioImageIT tutorial, we are going to see how to use BioImageIT with OMERO database. So as a reminder, I want to show the BioImageIT project architecture. So the main component of BioImageIT is the application programming interface. That is a single interface that's allowed to communicate with the components, the data management, and the data analysis. And each component is implemented with plugins. So for example, for data management, you have a plugin to have a local file system or an OMERO database. And for the data analysis, we can run the analysis tool locally with Conda, Singularity, or Docker, or in a remote server. And all these plugins are based on existing software or existing application. So BioImageIT is just an interface to make all this software communicate together. And in this tutorial, we are going to use the BioImageIT client. That is an application that you install on your computer with a graphical interface. And we are going to configure it to use it with the OMERO database and run the calculation locally on the computer. So first, let's start the BioImageIT application. So this is the main screen of BioImageIT. So I can see here some programs that I have locally. And by default, if I go into the settings, I can see that here I'm using the version 0.1.0 of BioImageIT. And if I go into the configuration, I have the default configuration from the installer of BioImageIT. So the data management is done locally, and the data analysis is done also locally using the Conda runner. So here I need to change the data management service into the OMERO service. It asks me some information to connect to an OMERO database. So in this tutorial, I'm using the demo server of OMERO. So this is the host address. The port number is given in the documentation, and I give my username and my password. So now I can save my configuration, and the application told me to restart for this new configuration to be taken into account. So I will close the application and start again BioImageIT. When I restart BioImageIT, I can see now my experiments are not the same because this is the experiment I have on my OMERO instance. So if I connect into my OMERO database, I can put my username and my password. And I can see that I have one experiment that is exactly the same one that I have on BioImageIT. So now I'm going to create a new experiment and give it a name, like tutorial deconvolution, for example. And I create my new experiment. So now it's created. And if I go and refresh my OMERO database, I can see that I have my new project. I can now import some data. So I click on the import button, and here I will import multiple data from a single folder. So here I go in the BioImageIT notebooks repository that is inside the repository of BioImageIT install on your own directory. And there are some fake synthetic data that I will use for this tutorial. So I select the directory, I open it, and now I have to fill some informations about the data I want to import. So all my files are TIFF files. So they are image TIFF format, and the other information are automatically filled with the application, and I click import. So depending on the speed of your internet connection, the import can be more or less fast. So when it's finished, I got this window. So I say OK. And when the data are imported, I have now the list of all the files I've imported into my project. And if I look into my OMERO project, I can update, and I see that I have one dataset called data with all my data inside. So as you can see, my data files have some names that contains population 1 and population 2, and each file also have a unique number. So here I'm going to extract this information to create some map to map these values to some keys and be able to recognize all the single images of the project. So for that, I have the tag button here, and I can manually create keys, but I can also extract automatically with these two filters. So first I will annotate using the name. So my key is population, and the two names I want to search into my files are population 1 and population 2. Okay, I click validate. So now it's processing. And when it's finished, I'm back to my dataset and I can refresh the view. And I have one extra column that is called population, and all the values are the numbers that are extracted from the file name. If I go to the OMERO database, I can select one image, and I see now I have a k-value pair with my key and my value that I extracted from BioImageIT that have been stored directly into the OMERO database. Now I can extract the numbers that are associated to each image. So I go back to the annotation tool, and now I go to annotate using separator. So I can say that I want to extract an ID for each image. And here the thing is that my ID is located just after the first underscore. So I'll say that my separator is my underscore, and I want to get the value that is just after the first one. So I click on validate. And I got the result. I press OK. And I have one extra column with the ID for each image. So this annotation step is very important for the analysis because it allows later to filter the image using these annotations. And for example, we can run processing tool on images that have only one specific value of one specific key. If we want to edit these annotations for each images, we can go to the metadata, and we have a form where we can edit the basic informations of the images and the annotation we just created. We can also visualize the images directly on the application with the view buttons. So it opens the data on the NAPA reviewer, and we can open as many images as we need. If I go back to my OMERO database, I can see that I have all my images and my two annotations are here. So I have the ID of the image and I have also the population of my image. And this is for all the images. So now we are going to run a deconvolution algorithm to denoise the images and try to have a better view of the spot and to be able to segment easily the spot with a basic threshold. So for that, in BioImageIT, we are going to the toolboxes, and we will use the deconvolution toolbox. And here I select the Spitfire 2D deconvolution because we have 2D images. So it's a classical graphical interface to run a processing tool. The only difference is that the input is not a single image, but it's an experiment. So I can select the experiment. So here I have only 2 experiments on my OMERO database. So I will use the one of this tutorial. And it already found my dataset. And it shows me a default name for my output directory, or my output dataset. I can here filter the images. So for example, if I want to filter only the image with some specific ID, I want to filter only the image with the ID 001, for example, and I say validate, my filter is on, and it will run the processing only on the images with the ID equal to 001. Here I don't want to do any filtering, I want to process all the images, so I don't put any filter, so my filtering is off. And then I can set the deconvolution parameter. So these parameters are specific to this deconvolution algorithm. So I will select the parameters I tried before, and I know that they are good for this dataset. I press run. So the first start can take some time because BioImageIT need to install first the deconvolution algorithm on the computer, and then it will start the computing for all the images in the sequence. I can go back to my experiment and refresh my dataset. So I can see now my new dataset with the deconvolution results. So now here I have all the details of the output results. So for each origin called parent image, I have an output image, and it says that it's denoised image using my algorithm. And I have also the annotations that are still here. If I click on the metadata on any image, I have all the description of the origin of this image. So I have the name, the author, the format. I have the IDs of the input images, the version of the algorithm I used to run on this to get this deconvolution, and also all the parameters of the deconvolution algorithm I set to get this result. And of course, on my dataset, I can also visualize the data. So for example, here with my image of ID 6, I can visualize the deconvolution on the input image. So of course the deconvolution denoising is not perfect, but it's good enough to be able to get the dots with a simple threshold. If I go back to the OMERO database, I can see that I need to refresh first, and I have my new dataset with all the result images. And the important thing is that for the full dataset, I have one attachment file that gives me the description of the run. I got here all the information of the algorithm and the parameters I used. And if I open one image, I also have one attachment that shows me the origin of this image. So I have the IDs and I can track all the origin of this image. So we saw here that using the BioImageIT client, we can configure it to run with OMERO, and all the processing are directly stored inside the OMERO database and nothing is stored locally. So all what we've done here with the graphical interface, we can also do it with the Python API. So we can open here the BioImageIT Jupyter notebooks. And in the BioImageIT notebooks, there is a tutorial about deconvolution. So we are going to open this notebook. Here I prepared a notebook with already prepared pipeline that we just show with the graphical interface, but it's exactly the same experiment, but with a Jupyter notebook. So first we connect to the BioImageIT API, so I can execute this cell. Okay, now I'm connected and it tells me that I'm connected to OMERO because it's the same configuration file that the one I used previously on the graphical interface. Now I can create a new experiment. So here the name is different from the previous one, so I can create my experiment and it will directly import some synthetic data. So it's exactly the same data set. It imports the synthetic data. And then I call two methods to use the annotation. So one method to annotate from name to extract my population 1, population 2, and one to extract a number that is located just after the first underscore character. When it's finished, I can go back to my OMERO client. I refresh and I see that I have one new, it's called Tuto Deconvolution from my Jupyter notebook with my dataset and all my images inside. And when I open the k-value pairs, I can see that I have extracted my number and my population keyword. If I go back to my Jupyter notebook, my third cell is the job to run the deconvolution. So I just create one BioImageIT job for my experiment and I set the tool I want to run. So here is the ID of my deconvolution tool with its version. I set the input request. So my request is the data dataset and my query is empty because I want to get all the images. And I set the parameters of my algorithm. And I say that the results should be stored in the dataset called deconv. And at the end, I just call the run command from the BioImageIT request. So I can run this cell and I can see that it will start the deconvolution process. So when it is finished, I can go back to my OMERO database. I can refresh and I see that I have my deconv dataset with the results images and again all the attachment files that gives me the information of the data origin. So as a conclusion of this tutorial, we saw that using a single user interface, we can design a classical image processing pipeline with the three usual steps like data import, data annotation, and then data analysis. This can be done using the graphical interface clients, so we can click on buttons and visualize the results directly on the interface, or we can also use the Python API directly. And we see that here in this example, we deploy it in the OMERO database. So everything is stored on the OMERO database, but of course, just by changing the configuration file, we can deploy the same pipeline in different systems.